Hey everyone, in this video, let's go through question 417, Pacific Atlantic water flow on Leetcode. This is part of our blind 75 list of questions, so let's begin. So in this question, you are given an M by N rectangular island that borders both the Pacific and Atlantic Ocean. The Pacific Ocean is basically touching the island's left and top edges, whereas the Atlantic Ocean touches the island's right and bottom edges, as here. The island is partitioned into a grid of square cells, and basically the M by N integer array we are given, the integer matrix we are given, represents the height of each of the cell. Basically, you can think of it like this. Let's suppose we have something like this. Let's suppose this right here is the Pacific Ocean, which is surrounding. Let's suppose this is the Atlantic Ocean in red. And then the heights is given like in the middle. So heights is basically, you can think of it like the height of the specific cell, right? So maybe this is like a mountain or like some region, but it's like it has different heights at different locations, right? So this is what you can think of it as. Now, what does the question say? So the question says that the island receives a lot of rain, and the rainwater can flow to the neighboring cells directly north, south, east, and west of the neighboring cell's height if the height is less than or equal to the current cell's height. What does this mean? This basically means that suppose that maybe like draw over here. Suppose that like this cell gets water, right? This cell gets water. Well, if this cell gets water, then it can go down here, right? Because this is all like lower. It can also like go all the way here. It can go here. It cannot go to like a higher place. It can't go like all the way up here. But basically the water can go all the way down here and maybe it can touch the Pacific Ocean. Maybe it can go all the way down here and touch the Atlantic Ocean. And here again it touches the Atlantic Ocean, etc. So let's read it again. The island receives a lot of rain and the rainwater can flow to the neighboring cells directly north, south, east, and west of the neighboring cell's height if it is less than or equal to the current cell's height, and water can flow from any cell adjacent to an ocean into the ocean. Okay, so what does that also mean? It basically means that like if it is over here, if the water like arrives here, it can basically like arrive at the ocean. So what do we want to do in this question? Well, in this question, we want to return the coordinates for any of the cells in which the rainwater can go to both the Atlantic and Pacific Oceans. What does that mean? So if we were to go back, let me erase a lot of this. So let's say we start off at this cell over here, and maybe I'll just zoom in a little. So let's say we start off at this cell over here. If we go down this path, we can reach the Atlantic Ocean. Maybe if we go down this path, we can reach the Pacific Ocean. There are different paths like this in which we can reach both the Atlantic Ocean and the Pacific Ocean. But we want to return all of these cells in which they have this property. Now, one thing you might already notice is that these corners over here are like this corner here, then like this corner down here, and then this corner down here. They will like, okay, I guess it's just these two actually. They will obviously be part of this list because they are touching both the Atlantic Ocean and the Pacific Ocean, so both of them. So those two will definitely be as part of our list that we return, but there will also be like many other cells over here that could potentially be our answer. Okay, so what does this mean, right? Like if you think about this one, if you think about this matrix that we have here, think of this as like a matrix of heights, right? So if you think about this 5 here, what it's saying is like from 5, where can we go? Well, we can go from 4 and then Atlantic, right? Here from 5, we can also go like maybe like 4 and 4, 4 and 2 to the Pacific. But basically, you can understand that from this 5 cell, we can reach both the Atlantic Ocean and we can reach the Pacific Ocean, right? So that's like one thing you can notice. Similarly, like from the 7 here, from the 7, we can reach the Pacific Ocean here. If we go down, we can also just reach the Atlantic Ocean. So there are certain cells that can reach both the Pacific and Atlantic Oceans, and we want to return these cells. Okay, so how might we go about doing this? Well, one way that I think, and anytime like you see like this type of graph problem or like matrix or anything like this, like you might as well think of like DFS or BFS, right? Like those are just like given. So one thing that I can think about is what if I was to maybe like start off, like maybe I can start off at like this one cell here, and I can see all of the cells that I can visit, right? And if any of them visit both the Atlantic Ocean and the Pacific Ocean, then maybe I can add this cell to my list of results. I could do that, but what do I notice here? Well, I notice that there's going to be a lot of cells like that, right? Because if this is an M by N matrix, so 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. This is like 25 cells. So do I really need to go through those 25 cells? I mean, that is one way I could do it, right? Like maybe I start off at this 5 and I see all the positions that I can reach. And maybe I can reach the Atlantic Ocean and maybe I can reach the Pacific Ocean. But do I really need to go through all 25 cells, right? Is there an easier way? If you think about this, the easier way is actually, why don't we just look at these cells over here, these edge cells over here? What I mean by that is if I go over here, and maybe let me zoom out, and I'll paste it in. Okay, so why don't we just look at these edge cells over here? These edge cells, I mean all of this for the Pacific Ocean and all of this for the Atlantic Ocean. Why don't we do a DFS call from here and see what are the cells that we can reach if we start from any of these positions? So what might that look like? Well, in the case for I is equal to this one, so let's say we start off here, right? So what are all the cells we can visit? Well, it looks like we can go down. And remember, this time we're just thinking in reverse, right? Here you would think about like going down or remaining on the same height. But if we're trying to see all the cells we can visit from this one, then it makes more sense to like think in the opposite directions. Like I want to go up, right? I want to go up. So that's how we can think about it. So from this cell, we can reach this one because we're going up. We can reach this one. We can reach this one. We can reach this one. We can also reach this one, right? What about here? Well, if we go down here, then can we reach the 2? No, we can't because it's lower. So we want to actually just go higher. So we can't actually do anything from after we reach the 3 here. We're stuck. What about from 2 here? Can we go anywhere? Yeah, we can actually reach this 2. And then we can reach this 4. We can reach this 5. We can reach this 7, etc. But basically what you see that I'm doing is that from all of these indices here, I'm finding out all of the nodes that I can visit. And if I know all of the nodes that I can visit on the Pacific side, then maybe I can do the same thing from the Atlantic side. So maybe from the Atlantic side, let me see. Let's say I consider this 4 over here. Or from the 4 over here, I can visit this 4, but I can't really go elsewhere, right? So that doesn't really help me. From this 1 over here, from this 1, I can see that I can visit the 3 here. I can visit the 4. I could also visit the 5. Now notice what this means. This 5, it can be visited by the Pacific like edges. It can also be visited by the Atlantic edges. If you think about what's happening here, if a cell can be visited by both the Pacific edges and Atlantic edges, that means that it's one of the answers to our question. That means it's like a point like this that it can reach the Atlantic Ocean and it can reach the Pacific Ocean, right? So that's another point that we can think about. What about the 7 over here? Like how might we arrive at the 7? Well, maybe if we start off at the Pacific, we can definitely reach it because this one goes up and we arrive at the 7. But let's see like how can the Atlantic arrive at it? So Atlantic, maybe it starts over here, and then we can see if we go up, we arrive at the 7. So notice that now 7 is being visited by both of them. So that's something we can basically check in this, right? So that's how we're going to go ahead and approach this problem. We can do a DFS call from the boundaries of the Pacific Ocean, from the boundaries of the Atlantic Ocean. We can see the common cells that they visit, and those will be our answer. So let's take a look at how we can write this in code. And the way I like to always do these types of questions, so I would just call this grid. And the way I always like to do these types of questions, so first of all, we should check if, okay, so it looks like m and n have to be greater than 0. So we don't have to check for like any cases where we might be like an empty grid, but we can nonetheless define our rows and define our columns, right? We define our rows and we define our columns. Now what? Okay, so now I need to do my DFS call, right? But where do I need to do it from? Well, I need to do it from a total of 4 places. First place, it's going to be this first Pacific row here. Then it's going to be this first Pacific column. The next place will be from this last Atlantic row and then this last Atlantic column. So how can we do this? So first let's see Pacific row. Let's see. Okay. So Pacific row we need to do it from. Pacific column I need to do it from. Atlantic row I need to do it from. Atlantic column I need to do it. Okay. So for Pacific row, what do I need to do? Well, I need to basically go through the first row. So this will be I in range 0, and then we'll go through actually the columns. And then I'm going to do my DFS call, right? I don't know what I'm going to pass in yet, but I'm going to do my DFS call. But what do I need to, what is my row and call going to be? Well, my row and column will basically be, the row will be 0, the column will be I, right? The row will be 0, the column will be I. This position here, the row is 0, the column is 0, 1, 2. Okay, let's talk about Pacific column. So for Pacific column, we want to go down this path. So how do we do that? Well, in this case, we can actually go to the rows for I in range 0 to rows. And then again, my self.helper. And my index will be, well, it's going to be the row, which is I, and the column, which is 0. Okay, cool. So now what about this one, this last one for the Atlantic Ocean, this last, or maybe we can start off with this last row here, this last row. How is this going to work? Well, in the last row, again, we're going through the columns. Well, what do we do? Well, what would the I and J be? What would the row and column be? Well, the row would be basically the last rows, right? So it would be rows minus 1. That would be the x coordinate. And for the column, it would just be I. Okay? And finally, we have this. It's the last column. So how do we do this? So in this case, again, we have 4i in range, 0. We're looping through the rows because we already know our column. And so my self.helper here, what would it be? Well, it would be the row would be varying. So the row would be I, and the column would be essentially the last column. So it would be calls minus 1. Okay? And so after we've done our DFS call here, basically we can aggregate all of the cells that we visited in both of the, like all 4 of these, in both of the oceans actually, and then we can arrive at our answer. So let's take a look at how we might be able to do this. Okay, so what do we need in our DFS call, right? We have helper, we have grid, we need row, we need call. What else do we need? Okay. Maybe it's important to also keep track of what? Well, we need to keep track of like the last cell we visited, right? Because, for example, if we, let me maybe remove all of this. So if we are maybe starting off, let's say we're starting off at this 1 over here, right? How do I know whether I'm allowed to visit this 2 or not? Well, it depends on the height of this, right? And the height of the previous one. Basically, the current element, the height must be greater than or equal to the height of the last one. So I need to know like what my last value is. So I'll say something like last val. What else do I need to know? What else do I need to know? Well, I don't know just yet, but maybe let me start coding and then we can see if we need to know anything else. Okay, so what are some of the things we always do in these types of questions? Well, we want to make sure we don't go out of bounds, right? So in order for us to make sure we don't go out of bounds, we have our general formula that we like to use. The first thing we do is we define the rows and columns again, and this could be passed in, but I like to keep our signature pretty like common, pretty small. So what can we do here? We can check if row is less than 0, or row is greater than rows, column is less than 0, or column is greater than calls. If this is the case, then we want to basically not do anything. We want to recurse back. We basically just return from here. Okay? What about another case? Well, now I know I'm in the grid, right? But I can check if grid at row and call. If this is less than the last val, well then I cannot like visit this, right? Because I cannot go from like 1 to 2. This is not allowed. So in this case, what we would have to do is return. Okay, so that's our second case that we have to return. All right, what else do we have? Well, now I know that I can visit a specific cell, right? Now I know I can visit a specific cell. So why don't I just basically like cache this that I visited this cell? Why don't I store it somewhere that I visited this cell? So maybe I can have like a scene array, right? A scene set. And then what I can do is I can do scene.add, and I want to add row and call, right? But before I do scene.add row and call, it's possible that like because it's a DFS, we might visit the same cell again, right? And so we don't actually want to do that. So what we can actually check is we can check if row call in scene. If that's the case, then what? Well, then we will just return, right? We don't want to do anything here. Now, if I have all of this, then the only thing I really need to do after this is recurse in all 4 of the other directions. So I'll recurse left. So let me just maybe fill this out. What will it be? Grid, row, call. What would the last val be? Well, the last val will be the current val, right? Grid, row, and call. And the scene will remain the same. And we have to do this for all 4 directions. So let's say we want to do left first. In left, the column decreases by 1. If we want to go right, the column increases by 1. If we want to go up, the column decreases, the row decreases by 1. If we want to go down, the row increases by 1. Okay, perfect. So this is our DFS call. So what it will allow me to do is that from this one index here, from this any location here, I'll basically visit all of the cells that I can visit. I'll add them to my scene array or my scene set, and then I will try to visit in all 4 of these directions. So now what we need to do is figure out what to pass here, right? What do we pass inside of this? Okay, so we actually know, first of all, we know grid, we know row here is 0, column here is I. What should the last value be? Well, the last value, if you think about it, when we're just starting off, then we want to make sure this is not false, right? Now, in order for this to be false, this last value, we need to actually make this the smallest value possible, because then this will actually be greater than that. So we will not run into this issue. So I can just do float minus infinity, right? Minus infinity. And then now, what do I need to pass in for scene? For scene, what do I need to pass in? Well, I might just pass in a set here, but if you think about it, this set should be common to basically the Pacific Ocean, right? So I can do something like P set, which means Pacific set, and then I can also do A set, which means Atlantic set. So here I would just pass in P set, which will be the Pacific set, And then here, I will just fill these in. So grid I0 float at minus infinity. And this again will be a p set. I'll fill this in. But here, I will pass in the Atlantic set. I float minus infinity, Atlantic set. And same thing here. I will pass in grid I cos -1, float minus infinity, and then the Atlantic set. Okay, so what have we done so far? Let's backtrack and see what we've done so far. So now we're doing a DFS call from this location, this location, this location, and this location. In our DFS call, we are basically populating all of the cells that we can visit in the P set and in the A set. Well, now what do I need to do? Well, now I can basically just take the common ground, right? I can just take the cells that are in both P set and in A set. And now we can basically just do an intersection. So this is kind of just cool Python thing, but basically all I need to do is I can do answer or res is equal to, what would it be equal to? Well, what I need to do is I need to add in, I can do P set intersection A set, right? Of A set. And so what would this return to me? This will actually return to me a set, right? It will actually return to me a set of something like, I don't know, maybe like a 1 and 2, 3 and 4, something like this, right? Now, we can't actually return this as the answer. Our answer, first of all, has to be a list, and it has to be like a list inside. It can't be like a tuple like we have here. So maybe I can call this like temp. And then for my result, what I can do is I can do for item in temp. I'll do res.append list version because it's going to be a tuple, right? I can do list of item. Then we just return. So let's see if we can run this or if we run into any errors because it's quite a big like thing we have to do. So okay, so one thing is grow, rid, and grow and call. All right, so I realized two errors that we made. So first of all, this one was hard to catch, but basically the infinity here should be a negative infinity. The second thing here is that this is wrong actually. Row should be greater or equal to rows. If that's the case. Same thing for columns. If that's the case, then it's out of bounds. We missed that as well. So now if we go ahead and run this, we go ahead and press submit. We've arrived at the answer. Perfect. So this time complexity of this, basically we're going through the entire array, so it'll be O of m times n. And also we are storing that basically in terms of the space in terms of the set as well. So at the worst case, it's okay, perfect. Thank you for watching.